Hello! Okay. Josie got scared a bit. Okay. So what we're going to do now, we basically got all information. We know all the families of equation. And I told the guys over here, page 134 and 135. Okay, whoa. Okay? It's got all the graphs and all the equations that we learned about. You really need to kind of, like I said, just squish that in. Just get it inside your brain any way you can. Just really memorize it. I'm going to come to your house Sunday night, wake you up in the middle of the night, and you're going to have to, like, I'll give you a hyperbola, and you have to draw it, okay? You have to already get it there, okay? Because, we've worked every lesson on a specific equation. But in a test, you're going to have to know all of them. So let's just do this little exercise together. You've got a bunch of equations. Let's sketch a very quick graph. In a test, you'll have to find the y-intercept, the x-intercept. We're not going to do that now because it just takes time, and we just want to make sure you know how to do it. Y equal 2x. What kind of graph is it? It's a linear. It's a straight line, okay? It's going to go up or down. Up is going to go up. Okay? Perfect. Okay? Let's do it like this. Okay, I'll just pause you here. Hang on. Okay. Again, we're going to just sketch all these graphs onto this axis, okay? So Sina said y equal to x is linear line going straight, going through the origin, by the way, because I don't have a b, okay? Y equal minus 2x over x plus 1. What is that, guys? What is that? Y equal minus 2 over x hyperbola. Okay, so thank you for that. It's hyperbola. Because I have a negative number here, it's flipped hyperbola. Okay, what does it mean that it's flipped? Okay, first of all, use the color. So it's not going to, normally they go like this and like that. Now it's going to go like this and like that. But we also have a vertical shift. So we have the asymptote, the horizontal asymptote pushed up. So it's going to be like this. Okay, this is 1. Okay, so that is this hyperbola. That minus made it flip. Normally it would be the other way around. And we've got a vertical shift. Let's leave that for a second. Y equal 2. Y equal 2. What is that going to look like? Horizontal line. Okay, horizontal line crossing at 2. Okay, that's y equal 2. X equal 3. A little bit more confusing. Good. A vertical line. Okay, vertical line crossing the x-axis at 3. Okay, let's say something like this. Okay, if this was a test, you probably will have to find out what these intercept. We're not going to do that. We've done that before. Okay, last one. What is that? What kind of function is that?
What's the one we just did now?
Exponents. Okay, right? That's exponents. All right. Let's try and answer that question one at a time. That's how you do it. Because this is 2, is that going to be taking off or landing down? Taking off. Okay, taking off. Because it's multiplied by 2, that taking off is going to be stretched even more, squished, or flipped. It's going to be stretched even more. And because I've got minus 2, what's that going to do to it?
Take it down.
Vertical shift down. So if we draw it, okay, it's going to be normally, okay, now I need to figure out where, okay, I'm going to do it. It's a bit complicated. But if I want to find out where the y-intercept, normally if I didn't have any of those, the y-intercept will be 1. Because I time it by 2, the y-intercept will be 2. Because I minus 2, the y-intercept is going to be exactly here. So it's going to look like white. It's going to be something like that. And there is going to be, again, a horizontal asymptote here, which is y equal minus 2. Now, this is not easy. It will take you longer than what I'm doing here. What I really want to focus here is how I can identify the function. Okay, so for this exercise only, I just want you to be able to realize, okay, that's an exponent, that's a hyperbola, that's linear, vertical and horizontal line. You got that. That's great. There's a lot of details to work out where the y-intercept, and in theory, you can do that. Okay? Let's move on to something a little bit more difficult. Right, chaps, next ones, this is, by the way, in exercise 5, we've done the A part, which is quite straightforward. B is where the trouble begins. So now, we don't always write down the function in a nice, decent way. You're being a little bit naughty. Okay? Let's have a look at this. X equals 3y. How can I write it as y equals something. What will it be? Y equal to?
3x.
Okay, so I'm going to write that down here. Y will be equal to x divided by 3. I want to get rid of that 3, so x divided by 3. Okay, and that is what kind of function? Y equal x over 3. Here we go. Okay, it's a linear graph, right? It's a linear. Okay, your linear graph will be y equal ax plus b. Okay, so the b in this case is 0, and the a will be equal to. Okay, so y equal x over 3 is the same as writing y equal a third times x. That's basic fractions. You got to know how to do it. Algebraic function. Okay, the linear function is y equal ax plus b. So there's obviously no b here, so we're going to the origin. A, which is your gradient, is a third. So it's positive, it's going up, but it's not as steep as, let's say, y equal x. Okay? So this is y equal third, or x over 3. Okay? Moving to something a little bit more difficult. Xy equal 3. What is that? So what we want to do is solve for x. That's what we want to solve for y. Sorry, we want to write it as y equal what? So what will be y equal to?
Minus 3 over 1. And 3 over x.
That's it. We're dividing both sides by x. To get rid of the x, we divide both sides by x, so it's going to be 3 over x. What kind of graph is that? Hyperbola, and it's a nice, decent hyperbola because that's positive. So it's going to be something like this. Okay? That was pretty easy, but all we're doing here is we have to isolate y, okay? Sometimes the x and y mix together. We will see it more and more and more. So we need to turn it into a decent way. It's called actually explicit and non-explicit way of writing the function. This is an explicit way, so you can see it's decent. Y equals 3 over x. And the non-explicit way is like this. It's like mumble jumble, everything jumbled together. Yeah? Now, y equal 3 minus 6 over 3. Now, I've got y equal to something, but as it's written now, it's a bit difficult to figure out what kind of function it is. So how can I write it as, to be able to identify it? It's going to be y equal to, what is 3 divided by 3? 1 minus x over 3. Okay? And you see what I've done? I've just divided the top by the bottom. Okay, you see what I've done? Okay, now what kind of function is that? I've got a feeling they're going to take a while. Okay, so I think I just need a little bit maybe of help. How did I go from here to here? So I'll just draw, you can see it. 2 minus 5 divided by 3. I can either say, okay, that 2 minus 5 is minus 3, divided minus 3 by 3 is minus 1. But another way of doing it, I can say, all right, it's the same as 2 over 3 minus 5 over 3, which is also obviously minus 1. So you can do that with fraction. You can also do it with when you have x's. So 3 minus x divided by 3 is 3 divided by 3 minus x divided by 3. So what is 3 divided by 3 is 1. So the function is y equal 1 minus x over 3. Now, what kind of function that? That must be a linear function. Because I've got x on its own. It's not x squared like quadratic. It's not x at the bottom like hyperbola. And it's not x as an exponent like an exponent. So it's just a linear. Okay? Your b, that's your y-intercept, is plus 1. So it's going to go through 1 here. Because I've got, what is the constants, the gradients, okay, what I'm multiplying x by is minus third, right? Minus x over 3 is minus a third times x. Okay, we've just done something similar but was positive. So the gradient is minus third, meaning it's going down. So it's going to be something like this. A straight line, okay? That's y equal 1 minus x over 3. Okay? Let's move on to the next. That looks very similar, but it's not the same. Y equal 3 minus x divided by x. How again am I going to write it in a better way? Exactly the same way. I'm going to do 3 over x, right? 3 over x minus what? Help me out. Minus? So I did 3 over x minus, and x over x is? Yeah.
1.
Okay, so minus x over x. Okay, let's write it down. Minus x over x. Okay, what is 3 over x minus x over x? Well, 3 over x is just 3 over x. I can't do anything. X over x is 1. X divided by x is 1. So that function is 3 over x minus 1. What kind of function is that? Now you can identify. It's hyperbola again. Okay, it seems like hyperbola. Okay, alright, 3 over x. Okay, so it's a normal hyperbola, just like that green one, okay, which was also 3 over x, but it's a little bit different. What is that minus 1? Vertical shift down, okay, so it's going to be, it has a horizontal asymptote of minus 1, x equal minus 1, and otherwise it's exactly the same as that green. Shouldn't get that there, okay, so it should be something like that. The vertical shift of that green hyperbola. Moving on, okay? Right, what do we do here, guys? You tell me, okay? How are we going to rewrite it? Y equal, before you tell me, maybe, can you think what kind of function is this? Any guesses? We don't, never mind. Okay, let's open it up. What is that? You know, there's a formula here that we should use. 3 minus 6 times 3 plus 6. Difference of the square.
Why bring this back?
We have to, yeah, that's, you know, everything comes back. Okay. Right, a plus b times a minus b. Anyone remember what is that equal to?
2a.
A squared minus b squared. Guys, you gotta remember those things. You gotta remember these things, okay? So when I have a difference of a square, a squared minus b squared is basically a plus b times a minus b. So you need to be able to work back and forth, back and forth. So in this case, 3 minus x times 3 plus x will be equal to? Okay, apply that. So the a in this case is 3, the b is the x, so the answer will be 3 squared minus x squared. Or in other words, what is 3 squared? 9. So that is the function. What function is it? Quadratic. If we have a square on the x, it's quadratic. So it's either happy face, sad face, happy face. What is it going to be? Happy face or sad face? I will write it slightly different. Instead of 9 minus x squared, alright, minus x squared plus 9. Sad face or happy face? Sad face, because it's negative. Okay, so sad face. Plus 9 means vertical shift upward. So it's going to be something like that. It's a sad face. Okay, and I can even tell what I can even say that this is going to be plus 9. And actually, thinking about it, I can figure out straight away what these numbers are. What is the y? Let's just add it now a little bit. We're going to learn it properly later, but might as well just do it now. What are the x values that will give 0, y? What should we put in x to get a 0, y? And that's the idea. We're trying to melt your mind. Okay? So, we know it's a sad face. Now, we are going to learn this bit properly in next week, but I want to just do it because we might as well with there. Okay? My question was, which values of x will give a 0, y? In other words, what are the x-intercept? The values of x that will give a y 0. Now, I think it was Georgia said here, x equals 3. If I put 3 squared, that's 9. Minus 9 plus 9 is 0. So one answer is 3. But the other answer is also minus 3. If I take minus 3 squared, that's also 9. Okay, and then minus 9 plus 9. So the other x-intercept is minus 3. But have a look how easy. That was a little bit difficult. If you use the first way of writing that function, if I ask you here what values of x will give a 0, y, it's much easier. Either x equals 3, and then 3 minus 3 is 0, and 0 times whatever it is 0. Or I put x equal minus 3, 3 plus minus 3 is 0. Okay, so when we write the quadratic function in this form, it's easier to know the x-intercept. Okay? Right. I'll pause here. There might be one more thing that we need to do. Right, the last kind of different one is y equal 2 to the power of x plus 1 plus 2 to the power of x minus 3. Now, if you had to guess, what kind of function is that going to be? Okay, we've got x as the exponent, so it's going to be, come on.
Exponential.
It's going to be exponential. But I've never, when we had an exponent, it was always a times b to the power x plus a cube. We didn't have two of those. So we've got a little bit of a problem. And look, they have different exponents. This is x and this is x plus 1. So I'm going to show you the trick. Okay? What you're going to do, and you have learned that skill last year, but you've never used it that way. What is 2 to the power of x plus 1? Is 2 times 2 to the power of x. Remember that from last year? Okay, rules of exponent. If I have a 2, it's basically it's 2 to the power of 1. So instead of writing 2 to the power x plus 1, I'm going to write 2 times 2 to the power of x. 2 times 2 to the power of x. Why am I doing it? Because now I've got the same power. I want it to have the same power. 2 to the power of x. Okay? Now I've got the same power. And I've got that minus 3. Okay, we're going to write it now. Now I can take a common factor, right? 2 to the power of x. What do I have to write in brackets here? If I've got 2 to the power of x, what are the two? How am I going to write it? Okay, have a look. I've got 2 to the power of x, the same common factor. So 2 to the power of x. The first one will be 2 plus, what should I do? Next one. Okay, the first one will be 2 times 2 to the power of x. How am I going to get the next one? What should I have here? Forget about the minus 3. Minus 3 will do it. Yes, Oli, we're going to have 1. 1 times 2 to the power of x will give it 2 to the power of x. Leave that minus 3 on the side. We're not putting it in this bracket. Okay, now, is there anything else I can do now? 3. Of course. I can say, okay, 2 plus 1 is 3. So y, final answer, is 3 times 2 to the power of x minus 3. Okay? Close the door, please. Close the door. Close the door. Close the door. Quick. Okay. So, without drawing this, just in words, that is definitely exponential. Is it going up or landing down? It's flying up. The minus 3 means it is vertical shift down. Okay? So we can do it. Guys, for homework. Okay? Do you want to read on OneNote what I'd like you to do? I'll put it on OneNote today. Okay? Cheerios, guys.